Hi everyone. In this video I want to walk through an application that involves composition. So in the context of a word problem, we want to be able to work with two functions, and we want to be able to use them separately to answer questions or together by composing them. And when we do compose them, we want to make sure we're really focused on the key pieces of information that we get from that. So we have the h of q function is the first function. Q is the amount of the drug in the person's bloodstream. Amount of drug in milligrams. And the output, H, is a patient's heart rate in beats per minute. Okay, so basically this function inputs how much of the drug is in someone's system, and then this is a drug that has a side effect of raising heart rate, so it will output their heart rate at that dose level. We have a second function. Q means exactly the same thing, so this function is outputting the amount of drug in milligrams. And this one is inputting the time since the drug was injected. And that is in hours. Okay, so again, I think the things to pay attention to here are when should we be using H, when should we be using Q, and when should we be using a composition. The first question we're supposed to answer is how quickly is the heart rate increasing or decreasing with respect to the amount of drug. So we would like to relate heart rate to amount of drug. That's going to come straight from the h of q function. There's no t part of this question at all. I don't have any time involved. So just h and q, which means I can entirely ignore the q function and focus only on the h function. So the h function tells me, this is linear, so the heart rate starts at 60 beats per minute, and it increases by 0.2 beats per minute for every additional milligram in the person's system. So because this is linear, I'm picturing h as outputs, q as inputs, and if my slope is equal to 0.2 over 1, that's going to be change in h over change in q. So again, for every additional milligram of the drug in their system, their heart rate is increasing by 0.2 beats per minute. So I think I'm just going to write that out. I don't think we need a whole sentence for the way that's asked, but I'm going to write it out with units. 0.2 beats per minute per milligram of drug. Okay, so this is definitely, part B is definitely a composition question. It asks you what you get when you're working with function h of q of t. So again, we want to see if what we're doing even makes sense. We're starting with the time since the injection in hours. We plug that into function q first. Function q is going to give us the amount of drug in milligrams. And then we will take that amount of drug and we will plug it into function h. And this looks like it's a perfect idea to do it in this order because q, amount of drug, is an appropriate thing to plug into h. If we tried the other way around and we did q of h, we would be trying to plug heart rates into this function down here that's looking for time. So that would be a bad idea. All right, so we take an amount of drug, we plug it into function h. The final thing we get out is the heart rate. The whole thing is the heart rate. Okay, so what h of q of t does is it tells you the patient's heart rate after t hours. So basically the whole point of making a composition in a problem like this is to skip over that middle piece of information. We already have a function that relates time to amount of drug. We already have a function that relates amount of drug to heart rate. Now we're looking to look at the relationship between time and heart rate and temporarily ignore the amount of drug information. So this guy gives heart rate after T hours. Okay, part C, how much of the drug was injected? So this one I would say has a hidden piece of information. I'm definitely looking for a Q, how much of the drug, but I need to figure out whether I'm being given my second piece of information is a piece about heart rate or a piece about time. And in this one, I would say it's a kind of a subtle piece about time. If we're asking how much of the drug was injected, the injection happens at t equals 0. So even though it's not worded as at t equals 0, that's what this part is getting at. So we are interested in relating t equals 0 to a q value. We will use only the q of t function. I'm going to plug 0 into q of t, and I get 500 over 2, which is 250, and that's milligrams. Okay, so they originally got 250 milligrams of the medication. Part D, according to this model, what would the patient's heart rate be if the drug was not injected? Okay, so this is a question about H, which makes me think that I at least need to be using H of Q, and then it's a matter of deciding if I need to use H of Q of T or just H of Q. We want to know their heart rate if the drug was not injected. So if the drug was not injected, that would imply that Q equals 0. So once again, I think it's a slightly hidden piece of information, but there is information there to plug into the function. So we would like to relate Q equals 0 to an H value, which means we're going to go to our H function and we're going to plug in 0. And we get 60. And I think I even mentioned that earlier, just reading off this equation. The heart rate started at 60 beats per minute and then increased by 0.2 beats per minute for every additional milligram of the drug in their system. So this starts at 60, does directly answer this last question. What was this, H? So I'm going to put units on, beats per minute. And I think that one looks pretty good.